So do you think for Newton's third law you can add things together?
Yeah.
No. Just know that Newton's third law, you cannot add them together. Okay. All moving objects have momentum. Momentum is a characteristic of an object, a moving object that depends on both mass and the velocity of the object. So what on earth does that mean? Anyone? Okay. What on earth? Okay, I'll read the second bullet. Momentum is a characteristic of a moving object that depends on both mass and the velocity of the object. What does that mean? Does it mean that the bigger the object and the faster? If I threw this at 1 meter per second and I shot this out of a cannon at 1,000 meters per second, which one has more momentum?
Cork.
Cork, why?
Because you shot him out of a cannon.
Because it's going faster. Velocity will make those out of PVC and shoot it up with pressure.
Really?
That's how they make marshmallow guns. Those are fun to make. Okay. So the second bullet, write that down, and also write the third one down. Momentum equals mass times velocity.
Is there only four?
There's 5. Okay. The unit of momentum is kilograms meters per second. So kg point m/s. Since mass is measured in kilograms and velocity is meters per second. You guys remember all those questions that you had about the kinetic and potential energy? That you're like, how do I label this? This is how you label it. It's kilograms or grams, depending on what it is. Dot, meters, slash, seconds.
Dot.
The velocity of an object is in the same direction as the velocity. The more momentum an object has, the harder it is to change its velocity. You guys remember me talking about NEOs? NEOs. Near Earth objects. Near Earth objects. NEOs. Yes.
Neos.
No. NEO is how it's pronounced. Near Earth objects. What are those?
There are objects in space that are near Earth and could hit it.
Very good. We come up with these really complicated terms. Kayla hit it directly on the head. It's an object that orbits near Earth and possibly could hit it.
Like a meteor? Like a meteor?
Meteor, asteroid,
Comet?
comets. Okay.
A rock? Planet?
It would cause lots of damage. Okay. Also, satellites are NEOs, or any space debris. They're all NEOs. Okay.
I got one.
What?
Like a disconnected planet or star could also be an NEO.
If it eventually got close enough, yeah, it could.
That would be so scary.
It would be scary.
Because, what would we all do? Like, you can't just, like, go somewhere.
That is a big problem, yeah. Okay, so I'm going to keep going. The whole scientific theory on us changing trajectory of a big NEO, think it's possible?
No.
It is, but if it has a tremendous amount of momentum because of its object, because of its mass and its velocity, is it going to be extremely difficult to change it?
Yeah.
Yeah. The higher the mass and the higher the velocity, the harder it is to change its direction.
It's momentum.
Right. It's almost impossible.
So if I was like running one way, like 4,000.
And the slowing down, how fast you're going to slow down, which is also acceleration. It all depends on
How fast?
if you're going to stop to go or continuous U-turn.
Stop to go.
Stop to go. That depends on you by a very long time.
Really? So what if I ran through
What if she
4,000 miles per hour? Would you guys be able to see me?
No.
Why?
Because
If
it's
you go really
Is that how
fast,
fast germs are? Is that why we can't see germs?
No, because they're small.
they're right in front there.
I was talking to you, Michaela.
Generally question.
you should just say
Okay,
speed of
keep going.
light.
Filling.
Try.
Okay.
No.
We done?
Nope. 10:45. 10:45. Wait, Mr. Weber, when are we
11:45. What time do we get out?
No, you guys are doing the test next week. Next Wednesday.
What do we do when we're done?
Okay, how many of you still have not finished 10.2?
I
What's
have
10.2?
to just write a couple more and then we're done with it.
10.2.
Duh.
But my